Okay, in this problem, we're given a table again. It says the table below models the price of a dozen grade A large eggs in dollars in the average U.S. city as a function of the number of months since December 1st, 2022. So in other words, January 1st, 2023 is month one. So I'm going to kind of come over here and write that down here. This is January, and then 2 months later would be March. 2 months after that would be May, then June, July, August, September, October, November, December, January. So 13 is January again. And so, if we continue on from there. Okay, so now Part A asks us to determine all the values of the rate of change and record the results in the table above. And what do these values tell you about the problem context? So just like before, we're finding the rate of change between the change in the output and the change in the the rate of change is the rate, the change in the output divided by the change in the input. So how much does the output change with respect to how much the input changes? And we're going to go right down through the table and look at every pair of numbers. And so the first one, I'm going to zoom in here a little bit. The 3.59 minus 4.75 is the change in my outputs. 3 minus 1 is the change in my inputs. And this gives me a result of negative 0.58. So I'm seeing here that each month between months 1 and 3, the price of a dozen grade A large eggs dropped by 58 cents each month. Okay, and if I continue doing that all the way down, the next rate of change is negative 0.42. So that's taking the 275, subtracting 359, divide the whole thing by 2, I get negative 0.42. When I continue on, I take this output 2.23, subtract 2.75, divide by 2, and I get a rate of change of negative 0.26. And you might be noticing here the price of eggs is dropping, right? It's dropping by a smaller and smaller amount as the months go on. Here it's dropping by 10 cents a month. All of a sudden, when I get to here, and I take 215 and subtract 2.03 and divide by 2, I end up with a positive value, 0.06. And so that's telling me that between months 9 and 11, on average, the egg prices increased by 6 cents per dozen per month during that time period. Okay, so then the next rate of change here is, again, larger, 0.22. And so just looking at my rate of change, I see that the eggs dropped by, over 50 cents a dozen for a couple months, a little less than 50 cents a dozen. In this time period, they dropped by about a quarter every month, by about a dime every month, and then they actually started increasing by a little bit and then increasing more each month. So I see that the change in the price of eggs was less and less each month, but then actually started getting larger and larger each month. So the rate of change is definitely not a constant, it's variable. And so the price of eggs was falling by less and less each month. I'll make it a little bigger than that. but then started increasing by more and more each month. Okay, so now it's asking me to find the rate of change, the rate of the rate of change, and record the results. So just like in the previous problem, I find the change in the rate of change and divide that by the corresponding change in the inputs. And so that would give me here negative 0.42 minus negative 0.58. Again, all over 2 because they're 2-month periods. And that results in a positive 0.08. If I were to continue all the way down, in each case, I get a positive 0.08. And you can check just to make sure here, 0.22 minus 0.06 all over 2 does indeed give me a 0.08. And so I see that the rate of the rate of change is constant. So I'm working with a quadratic formula here. And it says, what do these values tell you about the problem context? And so this is telling me that even though the rate at which the price of the eggs is varying, the change in the egg price changes is increasing at a constant rate. So these values here, this rate of change, is changing at an increasing rate of 8 cents a dozen per month. So let me try to write that out here. So this says the change in the egg prices changes. So the change in the egg price changes, the change in the egg price changes is increasing at a constant rate. So of 0 is increasing at a constant rate of $0.08 per month each month. Okay. So this value here is getting larger and larger, right? Less and less negative, so larger and larger at a constant rate of $0.08 per month. All right, and then it says use the values in the table to determine the price of the eggs on March 1st. And so I see that was January, March 1st, 2024. So this is 23, January 2023. This is January 2024. So the next would be March, and that would be 15 there. So again, like I did in the other problem, I'm going to kind of take my table, bring it down here so I can work with it. And there's $2.15 here, $2.59 in January. We're looking for how much it is in March. I know that the difference here is 22 cents. If I only knew this difference here, I could use that to determine the unknown value for March. So I'm going to have to use the fact that this difference here is 0.08. My table is going by twos, and that 0.08 is a per month So I'm going to need to multiply the 0.08 times 2 so that I can use the value in my table to find the next missing piece. So if this is telling me that over a 2-month period, the change in the price of eggs increased by 16 cents. So I would add 0.16 here to get 0.38. So now I know the rate of change between January and March, but that's a per month rate of change. So I have to take that per month rate of change, multiply it by 2, because my table is counting by twos. That gives me 0.76. So now I go ahead and take the 0.76, that was the increase in the price over the 2-month period, to come up with a new final price of $3.35 on March 1st.